China just quietly drafted a $295 billion plan to build an entire AI computing grid that locks Nvidia out completely. Not reduce reliance, not diversify supply. Lock out 80% domestic chips, by law, across a nationwide network of data centers. If this works, it's the first time any country has tried to run its entire AI industry on chips that are, by every public benchmark, a generation behind the best in the world. And the wild part is, it might actually work. Not because China solved the chip problem, because they stopped trying to. Here's what's at stake. If this grid actually comes online the way Beijing is planning it, every American chip company still counting on China as a future customer loses that market for good. Not shrinks, disappears. Nvidia already told investors China revenue barely moves the needle anymore. This plan is designed to make sure it never moves the needle again. For 3 years, the story of the US-China chip war has been simple. America bans the best chips, China tries to build clones, the clones are worse, repeat. Nvidia's Blackwell and the export bans around it were supposed to be the wall China couldn't climb. But over the last few months, China's engineers made a quiet decision that changes the whole equation. If you can't build a better chip, build a better machine out of worse chips. Stop competing on silicon. Compete on the system wrapped around it. And that shift just went from theory to national policy. Let's rewind to understand why. Nvidia's most advanced chips have been effectively banned from sale into China for a while now. First the A100 and H100, then even cut-down versions built specifically to satisfy export rules got caught in later restrictions. Huawei, China's national champion in this fight, doesn't have access to TSMC's most advanced manufacturing nodes. Its domestic foundry partner, SMIC, is stuck several generations behind on transistor density. On paper, that should be a fatal handicap. One Huawei Ascend 910C chip is roughly a third as powerful as one Nvidia Blackwell chip. The timeline of how we got here matters because it shows this wasn't one ban, it was a ratchet, tightening year after year. In August 2022, Washington cut off the A100 and H100 outright. Nvidia tried to comply by shipping down-tuned versions built specifically for China. The A800 and H800, the same H800 that DeepSeek famously trained its early models on. That workaround lasted about a year. By October 2023, the US closed that loophole too, banning the A800 and H800 alongside the originals. When Nvidia's next-generation Blackwell chips launched, they were restricted from day one. No China shipments, no workaround chip, full stop. There was one brief crack in the wall. In December 2025, the Trump administration reversed course just enough to let Nvidia sell its older H200 chips into China, under strict vetting, and a 25% cut to the US Treasury on every sale. But Blackwell and the newer Rubin chips stayed locked out completely. That's the pattern China has been living inside for 4 straight years. Every time it adjusts to one rule, the rule moves again. So Huawei did the only thing left. It stopped trying to win the one-on-one fight and started winning the group fight. Instead of one super chip, wire together hundreds of nearly good chips until the total output beats the competition anyway. That's the idea behind Huawei's Cloud Matrix 384 system, 384 Ascend 910C chips, connected through a custom optical interconnect, acting as a single logical machine. On raw compute, Cloud Matrix 384 outputs around 300 petaflops of BF16 performance, almost double Nvidia's flagship rack scale system, the GB200 NVL72. It packs nearly 3.5 times the memory capacity and more than double the memory bandwidth. On paper, brute-forced by sheer chip count, China's worst hardware just out-muscled Nvidia's best. There's a real cost to that trick, and it's a big one. Cloud Matrix draws about 4 times the power of Nvidia's equivalent system to get there. Efficiency-wise, Nvidia still wins by more than 2 to 1. But here's the thing about a country that's building its own power grid alongside its chip grid. Efficiency is a business problem. Being locked out of AI entirely is a national security problem. China picked which one it would rather have, and customers inside China are already voting with their wallets. Huawei's share of China's domestic AI chip market has been climbing from roughly 23% to nearly 28% in under a year, while total AI chip spending inside China is tracking towards somewhere between $36 and $40 billion annually. That's happening even though everyone buying these chips knows. On paper, they're getting less efficient hardware. When a market keeps choosing the worst option at that kind of scale, it's not confusion. It's a bet that supply security is worth more than raw performance right now. Exactly the bet Beijing is now making official with a $295 billion price tag attached. And they're not stopping at 384 chips. Huawei just laid out a roadmap that should genuinely worry anyone betting against them. Later this year, they're launching the Atlas 950, a super node packing 8,192 Ascend chips together. Stack enough of those into a full cluster, and you get the Atlas 950 supercluster, 64 of these supernodes wired into one system, more than 520,000 AI chips total, spread across over 10,000 racks, delivering a combined 524 exaflops of compute. That's not a data center. That's closer to a small AI-only power grid with a brain. Somewhere in Washington, that number, 520,000 chips in one country outside anyone's export control reach, is exactly the scenario the original chip bans were written to prevent. And Huawei isn't done. The Ascend 960 lands in 2027, the 970 in 2028, on a fixed annual release cadence, like they're daring the export bans to keep up. Before you buy the hype completely, though, here's the part Huawei's marketing conveniently leaves out. The Council on Foreign Relations ran the numbers on both companies' published chip roadmaps through 2028, and the gap isn't closing, it's widening. Today, America's best AI chips out perform Huawei's best by roughly 5 times on raw processing power. By 2027, on Huawei's own published roadmap, that CFR analysis projects the gap stretching to 17 times. There's an even stranger detail buried in Huawei's own numbers. The next generation Ascend 950PR and 950DT chips, both due this year, are projected to actually perform worse than the current 910C, a regression that analysts read as proof SMIC is struggling to manufacture at the scale this whole plan assumes.
EI's next-generation supernodes ship in volume. Underneath all of it sits a software problem that no amount of chip count can brute force away. Nvidia's CUDA platform has nearly 2 decades and 4 million developers built around it. Huawei's answer, called CAN, is real and improving, but every engineer who's tried porting production code over says the same thing. Friction, regressions, debugging headaches that don't exist on CUDA. Huawei knows it. That's why they announced their open sourcing CAN entirely by the end of this year, a quiet admission that the software gap, not the chip gap, might be the harder war to win. This is the strategic bet, laid out in plain terms. Beijing looked at the chip war, realized it could not win it chip for chip, and decided to change what winning means. If the fight is about the smartest single processor, the US wins clean. If the fight becomes about who can wire together the most processors, fastest, cheapest, at national scale, China thinks it can win that fight instead. That's why this new $295 billion computing grid plan matters so much more than it sounds. It's not really an infrastructure project. It's China formally switching the terms of the entire competition, in writing, as government policy. And that $295 billion isn't just buying chips. That's the part most coverage skips past. A supernode with 520,000 processors packed into 10,000 racks doesn't run on silicon alone. It needs power plants dedicated to keeping it fed, since Cloud Matrix-style systems already burn about 4 times the electricity of their Nvidia equivalents per unit of output. Multiply that across a nationwide grid, and you're talking about a genuine energy policy problem, not just a tech one. It needs industrial-scale cooling, because packing that many chips into a rack generates heat few facilities on Earth are built to handle. And it needs the optical interconnect hardware, the custom networking that makes hundreds of separate chips behave like one machine, built and installed at a scale nobody has attempted before. China's central planners have reportedly set a 2028 target to have this grid fully running on domestic chips. That's not a random date. It lines up almost exactly with when Huawei's Ascend 970 is scheduled to ship. The whole plan is timed to a chip that doesn't exist yet. Now, here's where the story takes a turn that most of the coverage glosses over, because this chip independence narrative has a crack running straight through the middle of it. Teardown reports on Huawei's Ascend 910C, the chip powering all of this, found something that should not have been there if China's story about domestic chips were fully true. Independent chip analysts pulled apart multiple Ascend 910C samples and found processor components originally manufactured by TSMC in Taiwan, plus high-bandwidth memory from Samsung and SK Hynix, both South Korean companies bound by the same US export restrictions Huawei is supposed to be locked out of. Investigators traced roughly 2.9 million of these smuggled TSMC dies flowing into China through a shell company acting as a middleman, before TSMC caught on, cut the relationship, and reported it to US authorities. So the chip China is betting a $295 billion national grid on is partly built from banked, smuggled, and stockpiled foreign components, supplies that don't refill once they run out. And they are running out. Analysts tracking the memory supply chain estimate China has secured enough smuggled high-bandwidth memory for somewhere around 1.6 million Ascend 910C packages total. Sizable, but finite, with local memory producers still nowhere close to filling that gap at scale. That's the spike in this story. China isn't just racing Nvidia on system design, it's racing its own stockpile clock. Every supernode Huawei ships is partly built on a shrinking pile of foreign chips that America and its allies are actively trying to shut off at the source. Behind the scenes, there's a second race running in parallel to try to close that gap before it becomes a crisis. Domestic Chinese memory makers, like Changshin Memory Technologies, are racing to scale up homegrown high-bandwidth memory production fast enough to replace what's currently smuggled in from Samsung and SK Hynix. But by most industry estimates, they're still meaningfully behind the volumes this plan needs, which means the entire $295 billion supernode strategy is quietly resting on a bet inside a bet that Chinese memory manufacturing can mature at national speed before the foreign stockpile actually runs out. If Changshin and the rest of the domestic supply chain scale in time, the smuggling story becomes a historical footnote, an embarrassing but temporary bridge. If they don't, every supernode after this one starts shipping with empty racks.
Which is exactly why the system-level strategy matters as much as it does. If you can't guarantee a steady supply of world-class individual chips, the smartest move is to make your system less dependent on any single chip being world-class. Wire enough merely good processors together with clever interconnects, and a supply hiccup in one generation doesn't sink the whole plan. You just add more racks. It's a hedge against exactly the kind of smuggling crackdown that's now closing in. And China isn't betting on Huawei alone. This is happening across the entire AI sector at once, which is what makes it look less like one company's strategy and more like a coordinated national shift. Z.AI just finished building a massive new data center that it's committing to fill exclusively with Chinese-made chips. No Nvidia hardware anywhere in it. A real-world stress test of whether the domestic-only approach can actually train frontier-scale models without a single foreign GPU in the building. If Z.AI pulls that off cleanly, it becomes the proof of concept every other Chinese AI lab points to when they justify going all in on domestic silicon. Even DeepSeek is following the same instinct, and DeepSeek is the company you'd least expect to bother. This is the lab that shocked the entire industry by training a frontier-level model for a fraction of what American labs were spending. The company that made doing more with less its whole identity.
DeepSeek is reportedly now designing its own AI chip, purpose-built for inference, running already trained models to answer real user queries, rather than for training new ones from scratch. The goal is explicit: cut dependence on both Nvidia and Huawei at once. When the most resource-efficient AI company in China decides it's worth the cost and complexity of building its own silicon rather than just buying someone else's, that's not a minor supply chain decision. That's a company betting its whole future that no outside chip supplier, American or Chinese, can be fully trusted going forward. There's a consequence to all of this that most coverage skips entirely, and it matters just as much as the chips themselves. Under China's national intelligence law, every organization operating inside China, including the state telecom giants building and running this new grid, is legally required to cooperate with government intelligence requests. No exceptions, no disclosure requirement, no way to legally refuse and say so publicly. Layer on China's cybersecurity law, which requires network operators to hand over technical assistance to security agencies on demand, and you get a plain fact. Any workload processed on this national AI grid, anyone's workload, foreign or domestic, is operating under a legal system where government access isn't a risk to manage, it's the baseline condition. That's not a hypothetical for the future. That's the law today, before a single new supernode goes online. There's an ironic twist to close the loop on all of this. Just this past week, reports surfaced that Beijing is now considering the opposite kind of export control, restricting Chinese AI models and chip designs from leaving the country at all, specifically to stop Western companies from acquiring what China has built. 3 years ago, China was purely on defense, absorbing one American restriction after another with no real countermove. Now it's drafting its own version of the exact same weapon, aimed the other way. The country that spent 3 years being locked out is now writing a playbook for locking others out. Put next to America's approach, the contrast gets sharper. Meta and Microsoft alone have committed more than $725 billion combined to AI infrastructure this year. Not government bonds, not a 5-year state mandate, just 2 companies competing for market share and shareholder returns. America's build-out is chaotic, overlapping, and driven by competition. China's is centralized, coordinated, and driven by a 5-year plan with a 2028 deadline stamped on it. One system bets on the market sorting itself out fastest. The other bets that a government that can force alignment across an entire economy beats a market that can't force anything at all. Neither bet is obviously right yet, but only one of them is being tested at the scale of an entire nation's power grid. So where does this actually leave the race? By the numbers, Huawei's brute force supernodes already beat Nvidia's best system on raw output, even while trailing badly on efficiency and running on a foreign chip stockpile with a countdown clock attached. America is betting that clock runs out first, that the smuggling gets shut down, the memory dries up, and China's supernodes starve before they scale.
China is betting it can outbuild that clock. Flood every gap with more racks, more chips, more grid, faster than Washington can close the pipeline. Only one of those bets pays off, and the answer won't show up in a speech or a sanctions announcement. It'll show up in whether Huawei ships chip number 520,001 on schedule, or comes up short.